What's up guys, welcome back to MISSO's Survival Guide to Java. In this video we're going to be talking about Chapter 2, Using Data. Now before we get into Chapter 2, I just want to say real quick, if you don't really understand this stuff from Chapter 1, like the concept-based stuff, I would definitely go back and review it and make sure you fully understand that stuff before moving on to Chapter 2 and further chapters, because from here on outwards we're probably going to be talking about syntax a lot and a lot of the real technical stuff that goes into writing code. We're going to be hard coding a lot more from this point onwards, so definitely make sure that you grasp the conceptual part of it, the conceptual part of programming entirely before moving on. So with that being said, let's get right into it. So the first thing we're going to talk about is constants versus variables. We kind of talked about variables in the last video, but real quick, before we talk about constants and variables, I just want to go over some math, take it back to algebra class. I'm sure you've heard the word variable before, specifically, in math class. So in math class, we have things called variables. You might have an equation that says something like 10x is equal to 30. A super simple equation. Now, x in this scenario would be considered a variable because it holds a certain value. And, if you work the problem out, you would find out that x is equal to 3. And so you can look at this equation right here and realize that x is just a placeholder for the value 3, and that x is a variable that just holds a certain value, and in this case the value is 3. So in that way that math uses variables, it's really similar in programming. So we also have variables in programming, but they function a little bit differently, but at its core they do the exact same thing. They're just placeholders for certain values. So we'll go over what a variable is first. So right here, it says a variable is a named memory location. So you give a variable a name and it has a certain location somewhere in your computer's memory. And what the purpose is that it's used to store one value at a time. So in the same way that x stores the value of 3, a certain variable that you name could hold a value that you assign it. And one thing that's critically important for variables is that you can change the value of variables. So as you go on in your program, the variable, whatever you decide to give a value to your variable, it can change throughout the program. And that's what makes variables fundamentally different from constants, because as you see up here in the definition of a constant is something that cannot be changed while the program is running. So kind of just to go over an example of what a variable is, we have a variable down here called oven temp. Now oven temp, which obviously stands for oven temperature, could hold a certain value. So maybe the temperature of your oven is like 300 degrees. So oven temp is just a placeholder for the number 300. So kind of like how x was a placeholder for 3, the word oven temp is just a placeholder for 300. So anytime you write the word oven temp in your program, you know that that just means that it's holding the value 300. Now in the same way, constants also hold a value, but the thing obviously that makes constants fundamentally different is that they cannot be changed. So in this example, they give you 460. Now, before we get into what exactly that means, we're going to talk about two different kinds of constants. So the first kind of constant you have is a literal constant. So we'll just go ahead and write the word literal here. And then the second type of constant you have is a named constant. We'll talk more about named constants as we go on in this chapter, but this right here is a literal constant. And what that means is that you're printing out the number 460. So whenever you print out the number 460, it's literally printing out that number. 460 is never going to hold any other numeric value besides the number 460, because obviously that's the number that it is. It's 460 and it's never going to change. When it becomes 461, it becomes a completely different number. So the value for 460 is never going to change. So that's what we call a literal constant. Later on you'll see what a named constant is, but we'll get into that later in the chapter. So that's just kind of a basic understanding of what a variable is and what a constant is. They both function in the same kind of way, but they're fundamentally different in that constants cannot be changed. So definitely keep that in mind. You're going to be using variables and constants a lot. So to move on, every variable has a certain data type associated with it. So depending on how long the number is that you put in your variable, whatever the value is, you have a different data type. So there's something called Java's primitive data types. So all the data types that you see right here are all called primitive Java data types. And all these primitive Java data types kind of help to identify what kind of data is being held in your variable. So you might have a variable called oven temperature, but it could be any kind of these data types. It could be a byte, it could be a short, it could be an integer, whatever it may be. So these data types are just kind of to identify what kind of data is being held within your variables and within your constants. If that sounds confusing right now, we'll get into more of what these data types actually do and how they function. So for each data type, they all have certain sizes. So let's go back up to these data types. So all of these data types all hold number values. So a byte, a short, an int, long, float, and double will all hold a numeric value, whereas char will hold a single character, as it says over here. And then a Boolean will always hold a true or false value. Now that's critically important to keep in mind, whenever you're trying to declare certain kinds of data. So when we get into kind of what the maximum and minimum values are of these data types, that just kind of means how many digits can each of these hold. So like we said, byte, short, int, and long, they all hold numeric values, but they're all critically different because they all hold values of different sizes. So maybe you have a number that can hold 127 digits in the numeric value of that number. So a byte is what you would use for something that can hold, a minimum of 128 digits and a maximum of 127 digits. But maybe you want to give a variable a value with a huge numeric value, so maybe you would use an integer or a long because you need to hold more digits in that certain data type. So if you're using a really, really long number, the maximum value is a lot bigger than, let's say, a byte or a short. So in that case, you just kind of pick and choose what data type you use. And in the same way, the size of their bytes are different. So if a byte has less digits in it, obviously it's going to hold less memory, so it's only 1 byte. Whereas a long holds lots of digits, and it might be 8 bytes. So, you kind of want to be more specific. So if you're using a small number, you're going to want to go with something like a byte. If you're using a really large number, maybe go with something like an int or a long. So now we're getting into how to name a variable. So there's certain conventions you have to follow when declaring variables and assigning them values. So maybe we have a variable called number of students. We want to assign a certain number of students that maybe are in a class. So right here we have the name number of students, and there's 80 people in the class, so we assign it the value of 80. But what else is important is that we have a data type that's listed in front of number of students. So that's just kind of the naming convention. So as you see down here, it says the first thing you have is the data type. It could have any of the primitive data types. It could be an integer, it could be a byte, it could be a short, it could be a long, whatever you choose. So the first thing you do is you declare the data type. So in this case, we declared int. And then after that, you have what's called your identifier, or just the name of your variable. In this case, the name of our variable happens to be number of students because that's what we're trying to assign a value to, is the number of students. And then you have an equal sign, and then you have the actual value that you want to assign to that variable. Now, one thing to note is that you don't always have to initialize a value to your variables. You could just create a variable and maybe give it a value later on. So like they did in this example, they have the word byte, so they declare their data type, and then they assign a number maybe called number of sections. They're trying to count the number of sections, that a course is being offered or something, but they don't quite know yet like what the number of sections is, so they don't even have to assign it a value at this point. All they have to do is just declare it, and then maybe when they do find out what the number of sections is, then they can just give it a value later on. So there's two ways to do this. You can either initialize it and give it a value right off the bat, or you can just declare the variable and just give it a value later on. So there's two ways of doing this, but one thing I'd keep in mind is this right here, is that's the naming convention of how you're going to be naming your variables and your constants. So definitely keep that in mind. Now, one thing to note is that for different data types, there's going to be different ways that you declare them, specifically for bytes and floats and longs. whenever you're declaring a byte, as it shows here, you have to cast it. Now, casting just means that whenever you're declaring the byte, it's the exact same naming convention. You have a data type first, you have your identifier, whatever you call the variable. Maybe they're trying to track someone's age, and then they have the value here. But the only thing that's different is that they have the word byte here in parentheses, and that is called casting a data type. So you have to do this for bytes, shorts, longs, and floats. So whenever you're using a byte or a float, you have to cast it. So in the same way that you casted the byte up there, you have the same thing with the float. So they have the data type, they have the name of the variable, they have the value of the variable, and then they casted it. So for floats, it's kind of different from byte. So in byte, you can have just the word byte in parentheses before the value, but for float, you can do that, or you can have maybe just put a little f at the end to indicate that this value is a float. One thing is that integers don't really have to do this. So if you look down here, if you want to find the number of people or something, it's the same convention. You have the data type, which is int, and then you have the identifier or the name of the variable called number of people, and then you just have the value. Integers are a little bit easier to deal with because they're just really straightforward. You don't have to cast them or anything, but just keep in mind that you have to cast bytes, floats, shorts, and longs. So there's just more examples down here of casting. So same thing as they're just casting another byte. So you have to have the word byte before the value of it. And if you want to look into these examples, just pause the video and just go over it. Make sure that you understand it. But we've already gone over some examples, so we'll just move on. So now we're getting into named constants. So earlier we talked about what literal constants were. So now we're getting into named constants. And named constants are very similar to variables in that you assign a certain name to an identifier and then you give it a value. And now the one thing that makes it different from a variable is that it does not change. So as it says here, named constants do not change during programming once declared and assigned a value. And so the way you differentiate between a named constant and a variable, the way you declare them, it's almost exactly the same. So you have to have some kind of way of differentiating between the two. And the way you do that is by having the word final precede the data type. So as you see in the example up here, it's the same thing. They have a double. They have the name of their identifier, whatever you want to call it. In this case, they call it tax rate, and they have the value. But one thing that's important to note is that they have the word final in front of it. So if you want to be able to identify between a constant and a variable, that's the way you do it. You just have the word final in front of the data type. So if you have the word final, then it's going to be a named constant. Now, one other thing to take note of is that constants are always written in all capital letters. So the name of their constant here, called tax rate, is written in all caps, whereas the name of variables would be written in lowercase. You would be camel casing it. And so that's two ways to kind of identify how to differentiate between a variable and a constant. So the first thing here is the word final, and then the second thing here is that it's written in capital letters. So why is this useful? Why do you want to use named constants? Why can't you just use variables? They seem easier. So the reason you want to be using named constants is that you can change the value at one location in the program. So let's say you have, like in the example above, they had tax rate. So let's say you're creating a program about tax and how to calculate tax. And tax rate usually doesn't really change. So you can just write that once, create it as a constant, and so you can keep on using that same value over and over again without redeclaring the variable every single time. And in that same line of thinking, let's say the tax rate changes. So let's say it goes from 8.25 to 8.5. So tax rate increases. Sometimes that happens. So instead of going back and changing it in every single line of code, every time you're using calculations with tax rate, you can just change it once wherever you declared it as a constant, and then it'll change the entire time in your entire program. The second reason, obviously, you can reduce errors that way because you only have to do it once, and it stands out as separate from variables, and we kind of already talked about that. So now we're gonna talk about scope, and scope is really important whenever you're dealing with programming and writing, different methods and where exactly variables are existing. So scope is defined as areas in the program which you can refer to a variable or a constant. So just know that variables and constants all exist within scopes. So for every scope, you're gonna have a variable or a constant within scope. So as it says here, a variable or constant is in scope from the point it is declared until the end of the block of code in which the declaration lies. So, that sounds a little bit confusing, but this is kind of referring to curly braces. So let's look at an example of what scope is exactly. So here's a quick example of what scope is. So scope is all about where you're declaring your variables and where the variables exist. And scope always takes place between blocks of code. And as we talked about in the last video, blocks of code are written within curly braces. So as you see here, we have two sets of curly braces. So everything between that set of curly brace is a block of code, and everything inside that block of code we'll call our scope. So in our scope, we declared certain variables. So in this case, we declared int number of students equals 80. And now, maybe we want to print out our number of students. So you just write, system.out.println, and then you can just print out number of students. And right here, number of students is a variable. So that obviously will just print out the number 80. As it says here, it displays 80. But let's say we exit our curly brace. So, as we said, the curly brace ends here. So let's say we want to print out a statement, but we want to print it out outside of our scope. So right here we have a print statement, exact same statement that was written as above, but this statement that's in green is going to give you a compile error because it's considered to be out of scope. So variables only exist within the scope that they are declared. So in this case, we declared number of students here within the scope of these two curly braces. So number of students only exists within the scope of those two curly braces. As soon as we exit the curly braces, number of students ceases to exist. So whenever you try to print it out the second time here, it's not going to recognize it because the system will process it as something that doesn't exist. It'll say, hey, what is number of students? I've never seen that declared before because it's only been declared in previous scopes. So whenever you want to print out that number of students again, it's not going to be able to print out because it's not in the same scope as scope that it was declared in. So one thing to take away from this, if anything, is that variables only exist within the scope in which they are declared. So you have to stay within the bounds of your scope in order to reuse the variable. And as we said, if you exit the scope and you want to use that variable again, it's going to give you a compile error because it's out of scope. So we talked about kind of the numeric data types. We kind of talked about double, int, float, long, short. All those values hold numbers. But there are other data types that may not hold numbers, and one of them is a Boolean. So Boolean values will always hold either true or false. A Boolean will never hold anything but a true or false value. It'll always hold the word true, or it will always hold the word false. A Boolean is never going to hold a number, it's never going to hold a word, it's never going to hold a character, it's just going to hold a true or false value. So as we see here, you can declare Boolean. So you have a Boolean, you declare Booleans in the same way that you declare a number. So like we had int number of students equals 80, you can have Boolean, and then, is it payday, which would just be your identifier, and then the value is false, which is kind of sad, so I guess it's not payday. And I guess, are you broke, the value is true. So you're declaring it in the exact same way. And so Booleans act as kind of like a check. So if you were going to check, is 6 smaller than 5, which is what they call their identifier here, you could just do Boolean is 6 smaller, which is, you can call it whatever, equals 6 less than 5. And so if 6 is less than 5, then it would, display true. But obviously, like mathematically, 6 is greater than 5. So now this value here is 6 smaller would hold the value false, because 6 is not less than 5, 6 is greater than 5. So 6 isn't smaller. So you can do like arithmetic checks using Boolean. So, if your arithmetic is false, then the variable here will be stored, the value of it will be stored as false. And if it's true, then the value will be stored as true. So Booleans kind of act as like a truth check to certain statements that you want to check. So moving on. As we talked about, if you're going to want to like check certain things in Booleans, you can use what are called relational operators. So relational operators would be something like a less than sign, a greater than sign, equal to, less than or equal to, greater than equal to, or not equal to. So these are all just arithmetic checkers to check if something is relational. That's why they call them relational operators, because that's how you check the relation between one value and another value. And typically, these are going to be in Booleans, and they're all going to hold a true or false value. One thing to note here, this is all kind of like math, just less than, greater than, but the equal to here is a double equal sign. So definitely keep that in mind, because a single equal sign is used to declare certain variables. So as we said above, if you want to declare something like int number of students equals 80, we use the equal sign in that case as an assignment operator. You want to assign a certain value to a certain variable. So if you want to ever perform arithmetic checks, you can't use a single equal sign because that already exists in Java. So if you want to perform math checks, you have to use a double equal sign. And then, not equal to, the operator for the word not is an exclamation mark. So you just do exclamation mark equal to, which just means not equal to. And these are all just relational operator arithmetic checks. Now, as we talked about earlier, data types, some of the data types actually hold numeric values. So, like we said, double, float, int, byte, all these data types, they all hold numeric values. So what happens when you want to use decimal points as a numeric value? You can't store decimal points in an integer or a byte. You have to use either a float or a double. So floats and doubles exist so that you can use them to store values that have decimal points in them. So you can't use integer or byte to store decimal points. You can only use a float or a double. And so one thing to note here is that it says a float is less precise than a double. And the reason that is because a float takes up less space. So, we talked about, data types holding certain digits. So a float here holds less maximum digits than a double. So obviously the maximum digits in a double are, immensely bigger than the maximum digits that you can hold in a float. And so the reason why floats are less precise than doubles is because, let's say you have an extremely large number. Maybe you have a number that exceeds the maximum number in a float. So if we have a number that exceeds that maximum limit, if we go over it by like 0.321, it'll cut off whatever doesn't exist within the limits of a float. So, that 0.321 will get cut off if we exceed the digit limit. Whereas in a double, the digit limit is obviously a lot bigger. So if we use the double, it's more accommodating to more digits, which makes it more precise. So that's one thing to note. That might be on your exam or something. So definitely keep that in mind. Now, one of the last data types that we're going to talk about here is what is called a char data type. Now, a char is kind of exactly what it sounds like. It holds any single character. And, it's not just letters and numbers. It can hold like a colon or, just symbols that exist on the keyboard. And now the way you declare a char is really similar to the way you declare any other data type, the way you're declaring numeric data types or the way you're declaring Boolean data types. It's just the data type and then your identifier, whatever you want to call it, and then the value. So, you'll notice that the way you declare data types for variables or constants are very, very similar. But one thing to note here is that whenever you're going to be declaring a char, you have to use single quotation marks. So as you can take note of, whenever they declared, my middle initial, so whatever your middle initial may be, in this example, it's M. So whenever you declare the value of M, you have to have these single quotes that exist here. So you have to make sure that you have that, because if you're not putting single quotes there, it won't cast it as a char. So having those quotes there are extremely important. So that's kind of how you cast a char. And chars only hold single characters. So you're never going to have more than one, more than one letter in a char, or more than one number. It's always going to be one number, one letter, just one single character. So now, in addition to chars, we have something called strings. So chars kind of hold single character values. So you may be asking, well, how do we write entire words? Because chars can only, print out single letters. So the way you write like words or phrases in Java is using what's called a string. One thing to note is that string was not mentioned in the primitive data types because string is not a primitive data type. String is a built-in class in Java. So on the exam, if it asks you what are all the primitive data types, you would not include string in the primitive data types, although you kind of cast a string in the same way. You declare strings in the same way you would declare a data type. So strings are here so that you can store and manipulate strings of text, and you assign it using double quotes. So you use single quotes for char, and you use double quotes for strings. So in the same way that we talked about earlier, you have your data type, which is a string, and then you have whatever you want to call your variable, your identifier here. In this case, they call it my college, and you have your equal sign, which assigns a value to my college. And so in this case, they have it as Bauer. So the value of my college is Bauer. And take note of the double quotes that they have here. So that's important also to keep note of whenever you're declaring strings. So you can have more than one word in strings. In this case, they only have one word, but strings can be multiple words, as phrases if you want. One thing to also take note of is something called escape sequences. And a bunch of escape sequences start with a / followed by a character, as it says here. So an escape sequence represents single non-printing characters. So as it shows here, they have a string called my address, and they have a value for that. They have their entire value. But one thing to take note of is that in the value, they have a little escape sequence here. They have a / and an n. And, escape sequences, they do a lot of different things, and we'll look at that in a little bit. But just take note of the fact that escape sequences exist, and they do certain things. And they all start with a /. And I'll show you an example in a bit here. So these are all the escape sequences that you can use. You can use these escape sequences anywhere in your strings. Maybe you want to go backspace, so you can use /b, and this one does a backspace, /t does tab. But the one you're going to be using the most is probably /n, which creates a new line, and it moves the cursor to the beginning of the next line. So in that example, they have 334 Melcher Hall, and they have their escape sequence here /n, and then they have Houston, Texas, and then the rest of the address, the zip code. So whenever this actually prints out in your text editor, it's going to have this first, so this will be printed, and then it'll skip a line, and then under it, it'll print this. So that's what escape sequence does. So in this case, that's the functionality of it. It allows you to skip a line. If we put /t, then maybe it would just tab over. So there's different things that these escape sequences do, and like I said, the one you're going to be using the most is /n. So real quick, let me just show you a quick example here. So, I've written a string here, right? So the string, if I print it out, if I run the program, it shows up normally. But let's say I want to skip a line between here and here. So I'll just go ahead and write an escape sequence. So I'll do the / and I'll write an n. Oops. So I'll do /n, and then I'll run the program. And as you can see, between this word and the next couple words, it skipped a line because that's where I put the escape sequence. So that's kind of the functionality of an escape sequence, kind of just to demonstrate it and give you a better understanding of it. So moving on, we kind of talked about doing arithmetic and doing math, but with relational operators. But now you can actually do math in programming languages with arithmetic operators. So in the same way you use like a calculator to calculate certain things, you can use Java to do your math for you. And so, you've obviously already seen a lot of these signs before. So a plus sign is addition, subtraction, multiplication, and division. So it's written the same way in Java. So if you have like 45 plus 2, the result is going to be 47. One thing to know, which is kind of new that we've never seen before, is this sign right here. So it's a percent sign, but it's called a modulus. It's called a modulus right here. And what that does is it calculates a remainder for you. So what that means is that it does exactly what it sounds like. It just calculates a remainder. It doesn't do any division for you. It just calculates what is left after you do division. So in the example here, 45 divided by 2 is 22 with a remainder of 1, because obviously 22 times 2 is 44. So whenever you do that, you have a remainder of 1 in order to get to 45. So keep in mind that modulus and the remainder operator doesn't do division for you, but rather it just provides you with a remainder, kind of what is left over after the division that's already been done. So one thing to note here is that you really want to be really efficient in the math that you're doing. You don't want to just repeat yourself unnecessarily. If you can be as efficient as possible, then do that. So in this example here, they have, they're calculating certain things. So they're multiplying hours and rate over and over again. They're multiplying hours and rate. So instead of just multiplying it over and over again in order to calculate, whatever they're trying to calculate here, you can just create a whole new variable. So obviously hours and rate here is the way that you calculate someone's gross pay. So maybe we can just create a whole new variable and call it gross pay, and then just have hours times rate there. And then anytime we try to do more math, we can just have gross pay times the same rate, the state rate and the federal rate. But now we're being more efficient because instead of retyping the gross pay every single time, we've just created a whole new variable, called it gross pay, and now the hours and rate here just exists in gross pay here. So that's just an example of how to be kind of efficient with the math that you're doing. And just like when you're doing normal math, there's a certain precedence to when you're doing it. So kind of in math, I think it was called PEMDAS. So like for PEMDAS, you do your parentheses first, you do your exponents and your multiplication, division, addition, subtraction. So in that same order, you're still going to be doing that in programming as well. So in this case, if you have 2 plus 3 times 4, the first thing that comes first is multiplication. So 3 times 4 is 12, plus 2 is 14. But let's say you have parentheses here. You're going to do the parentheses first. So 2 plus 3 is 5, and then 5 times 4 is 20. So the answers completely change depending on the precedence. So this is probably something you've already seen in the past, kind of just how math works. So just note that it's the same way in programming and in Java. So one thing that's unique about Java is that the plus sign in Java does multiple things. Not only is it used for arithmetic and addition, it's used for something that's called concatenation. So you can concatenate certain things when you use the plus sign. So concatenation just means putting things together. Just bringing two things in a string and combining them. So in this example, we have declared a variable called billing date, and it's declared as integer and it holds the value 5. And so we want to, maybe tell the user when bills are being sent out. So you have a string here that says bills are sent out on the blank. And then you have billing date, which is 5. And then, down here you have next bill, October, and then billing date. But in this example, we have a plus sign here, which is concatenation. So if you look at the output, kind of just match up the words to where it goes. Right here we have, bills are sent out on the. So in the same way, in the output we have bills are sent out on the, and you have a space, and then you have the billing date. You print out the billing date, and then, obviously after in the print line. So in that way, right here, billing date prints out 5. You print out 5 down here, and then you have TH for the 5th. So that TH gets printed out right here. But in that same way, you can also concatenate it so that you don't have to write 3 different lines of code every single time. So maybe, in this case, they want to know when their next bill is. So in this example, their next bill is on October 5th. So next bill down here is the same thing as what they wrote up here, next bill October. And then the 5 comes from the billing date over here. So billing date obviously has the value of 5 because we declared it as 5. So whenever you do plus billing date, it shows up as 5. So that way you can concatenate certain variables into your print statements so that you can just combine everything into one line. But one thing to note that they mention up here is that numeric variable concatenated to a string using plus sign makes the entire expression a string. So the reason that's important is because whenever you declare the integer up here, billing day as 5, it's obviously an integer. That's the data type that you declared it as. You called it int billing date equals 5. So it's an integer. But whenever you concatenate it in this line right here, it becomes next bill October 5th, as we see down here. So this entire line right here is actually going to become a string. Although it holds 5 in billing date, and 5 is an integer as we declared at the top, whenever you print it out, and as soon as you concatenate it in a print statement or with any other string, the whole thing becomes a string. So 5 now becomes a string because it's set into the statement here that says next bill October 5th or October 5. And so that whole line becomes a string. So it ceases to become or to exist as a variable that is an integer. So now when we're doing math with these arithmetic operations and with certain numeric data types, there's what is called numeric type conversion. And the reason that exists is because you can do math with different kinds of data types. So you can do math with integers and integers, or you can do math with integers and doubles. So maybe you want to multiply an integer with another integer. So when you multiply an integer with an integer, it retains the same type. So it retains the data type and is still an integer. So anytime you do an integer divided by an integer plus an integer times an integer, it remains an integer. But if you use int and double, let's say you multiply a double and an int, Java doesn't know what data type to use, so it chooses a unifying type. And a unifying type is just defined as a type in which all operands in expression are converted to for compatibility. So what that means is that Java picks either an integer or a double to just convert both of them to in order to unify it into one single data type. And that just makes it a lot easier for Java to process it. Now, unifying types have a certain hierarchy. So it starts with double, it goes to float, long, and then int. So in that previous example, when we used a double and we used a float, and we multiply them by each other, it's going to choose the output will be a double. Because a double is the higher unifying type. So anytime we multiply a double and an int, the result that you get is always going to be a double. So the int gets promoted to being a double. In the example down here, we have an integer called hours worked, and it's declared as 37. We have a double here called pay rate, and it's declared as 6.73. And then you want to multiply both of them. So when you multiply them, the hours worked, which is the integer here, gets promoted to being a double. So whenever you're multiplying two different kinds of data types, you promote the lesser one to the data type of the higher one. In this case, the integer gets promoted to being a double. So as we discussed in the last slide, there's ways that Java does the conversion for you implicitly. It just kind of defines what the higher type is, and then it converts both of the numeric values to that higher data type. But there's also a way to do explicit conversions, which is when you can cast something explicitly in order to get the desired result, and it forces a value of one data type to be used as a value of another type. So let's look at the example here. So in this example, they have a float, they call it my money, and then they cast it as 47.82. And one thing to note is that, remember, anytime you're using a float, you have to typecast it. So that's why they have the F down here. So remember, floats, long, shorts, and bytes, you have to have some kind of convention for casting them. So that's why they put the F at the end. But let's say we want to convert this float into an integer. You can do that by just declaring another integer value. So you have int down here, and then you have something called dollars, which is just your identifier. You just made up that name as the name of your variable. But now you want to convert my money here, which is a float, into an integer called dollars, which is here. So you can just write my money over here, which is the name of the float, but just cast it. So casting is whenever you declare something in a parentheses before the value. So in this case, you cast it as an integer here. And so when you cast it as an integer there, right here, it becomes an integer. So my money, which was a float in the line above it, now becomes an integer. So it's pretty simple. That's what you call typecasting, just putting the name of the data type in parentheses before the actual value. But one thing to note is that you can possibly lose data whenever you're doing this. So like we said in previous slides, floats and doubles are used for decimal points. But obviously integers don't have decimal points. So let's say you're changing 47.82 into an integer, you wouldn't retain the 0.82 that comes at the end, because an integer can't hold this 0.82 after the decimal point here. So an integer would just drop the 0.82, and it would now only be valued as 47. So that's why sometimes you can lose some data and things can be inaccurate whenever you're trying to do this. Now, one thing that we kind of touched on in the last chapter is something that are called dialog boxes. So I showed you guys an example of a dialog box. A dialog box is kind of something it's a little pop-up that shows up on your screen, and maybe that pop-up will either display a certain message, or it'll prompt you to enter something, or it'll tell you to press OK or cancel or yes or no. So that's kind of what a dialog box is. And as we said, in the last chapter, if you remember, anytime you want to code a dialog box and actually program one, you have to have this import statement here. We showed a little bit of examples of coding in the last chapter, but I told you guys the first thing that always comes at the top of your program is the class header. But anytime you're using a dialog box, the dialog box goes up, or rather the import statement goes above the class header. So this import statement you see here, which says import javax.swing.jOptionPane, that always goes above the class header, and then that allows you to use dialog boxes in your code. So I'm just going to kind of dissect what each of these words mean, what javax, swing, and jOptionPane means. So on the side, I just made some notes here. So javax right here is a library that exists within Java. So there's a bunch of packages, a bunch of methods that exist in the javax library. So you have the library .swing, and swing is a certain package that exists within Java. And that package allows us to access the jOptionPane class. And jOptionPane is actually where you get, these dialog boxes from the jOptionPane class. So that's kind of the breakdown of it. You have your library, and then within that library you have your package, and within that you have the class, which allows you to access these certain dialog boxes and these jOptionPanes. So instead of just, there's two ways of writing the import statement. You could write javax.swing.jOptionPane, or you could write javax.swing and just have this little asterisk at the end. The asterisk at the end just kind of implies that you want to include all classes. So you could write it, that way. You can write it the way that has .jOptionPane, or you can just write javax.swing.asterisk. Either way will work whenever you're trying to code a dialog box. So let's talk about the first kind of dialog box. It's called a show message dialog. And show message dialog here is a method that we're going to be calling upon in order to, display a certain message in a dialog box. And so the actual code that you're going to want to write when you're writing a dialog box for show message dialog is right here. You want to call the jOptionPane class .show message dialog. So you have jOptionPane, which is the class, and then and then you're calling on the method, which is called show message dialog. And one thing to note is that there are two arguments in this method. So just kind of explain what arguments are. Arguments are whatever exists within the parentheses of a method. So certain methods accept certain parameters and stuff like that. And so in this case, the show message dialog accepts two parameters. It accepts the argument of null, and then it accepts whatever string that you want it to display. So you have null, and then you type out whatever string you want to pop up in the dialog box. So hopefully that's not too confusing. We're going to look at some examples here. So in this example here, we're going to be creating two dialog boxes, which is displayed down here. And the way you do that is, like we said, the first thing you want to start with is your import statement. So you want to import, the entire library, or rather the entire package of the JOptionPane class. So you have the import statement above your class. And then let's get down to the code that actually exists within the main method. So the first thing they do is they declare a certain integer that has a value here, int credit days equals 30. So now the value credit days holds the value 30. And so they want to display that in a message box. So you have the code here which says JOptionPane.showMessageDialog, which is what we set up there, that's the syntax for it. And then when you open parentheses, you start with null. That's the first argument, is null. It's always going to be null. Don't worry about what it is. Just know that anytime you have a show message dialog or any other kind of JOptionPane dialog boxes, you're always going to start with null. And then you have your string. In this case, they don't have any words or letters in their string, so they just declare it as an empty string. And then they concatenate credit days here, which is 30. So this code right here is what allows you to display this dialog box here. So you have JOptionPane.showMessageDialog. You open your parentheses, you have the word null, and you have a little comma here, and then you have your string, and they concatenate that string with credit days, which holds the value 30 here, if you can see that. So that just allows it to display 30 here. And then show message dialog is just a dialog box that pops up that, if you want, it prompts you to press OK. It just shows you a message. That's it. And so they create a second dialog box here, which displays something a little bit different. And in this case, they actually have a string. So let's just go through the code. It's the exact same thing. JOptionPane.showMessageDialog, which is the code here. They open their parentheses. They have the word null. They have their comma. And then as soon as you're done writing null in the comma, you start your string. So they want to tell you when every bill is due. So in this case, they say every bill is due in space. Spaces are critical because if you forget the spaces, then the 30, this space down here will cease to exist between in and 30. So you want to have a space between in right here. So they keep a space there. So it says every bill is due in space, and they concatenate credit days again. So credit days here, which holds the value 30 up here, which is what we talked about because they assigned it that value. And so then 30 gets displayed right here in the dialog box, and then they continue with the concatenation. Credit days plus, and then just the word days. That's a string because it's written in double quotes, like we said. So that credit days here is a variable that they use, and then that the words every bill is due in blank days is a string because they write that in quotes. And so that code right there allows them to create this dialog box here. So hopefully you guys can see that and it's not too complicated. So one other thing you can do with dialog boxes, which is actually kind of neat, is that you can take input from the user. So maybe you want to ask the user a question and you want them to give you information back. That's what you would call a GUI input. In this class, you're not going to be using scanner in this course. So if you see the word scanner in your textbook, just don't even worry about that. Definitely look at the book notes to see if you're reading the right stuff in the textbook. So you can use, like we said, dialog boxes for user input. So you have what's called an input dialog and a confirm dialog. So there's going to be 3 total types of dialog boxes we're going to be working with in this class. You have the show message dialog box, which we talked about up here, which just displays a certain message and just has an OK button. And you have input dialog and confirm dialog. So let's jump into what input dialog boxes are. So in the same way that show message dialog has a certain method, there's a method called show input dialog. And what show input dialog, it's kind of structured in the same way as a show message dialog, but this one is different in the sense that it asks the user a question. So it provides a little text field for the user to respond in. And in the same way, it has 2 arguments as the show message dialog version of the method. So again, the first argument is null, and the second argument is the string you want to display. So it's the exact same thing as the show message dialogues. So within the parentheses, you're going to have the word null, comma, and then you start your string, whatever you want to ask the user. And then it's going to return you a value. It returns a value because obviously you're asking the user a question, so the user is going to give you a certain response, and you want to store that response somewhere. So in this example of using a show input dialog box, which is the dialog box that we're creating down here, we're creating both of these. So this one is an input. So let's write that here. This is an input. And this one is a message dialog, which we talked about earlier. So like we said, an input kind of asks the user a question. It provides them with a text field to write something in. And then, you can hit OK or cancel, and then show message just shows you a message, and then you can just, click OK. So like we said, the first step is obviously to import the statement up here. You have the import statement, and then one thing to note with the import statement is import statements always have a semicolon. So never forget the semicolon import statements. Class headers and method headers don't ever have semicolons actually, but import statements do. So definitely keep that in mind. So let's jump into the main method here. So let's see what they're doing. So like I said, whenever you're having an input dialog box, it's going to be taking certain information from the user and storing it. So in this case, you're asking the user, what is their name? And so once you get that response from the user, you want to store that somewhere in the same way that you're storing the value of a data type. If you're storing the value of an integer or a byte or something, you have to declare that variable. So in this case, we want to store the user's name, so we declare a string, because obviously, the response the user is going to give you for their name is going to be a string. So you have string result here, so they're just declaring it. They're not actually assigning it a value yet, they're assigning it a value later on. This is another way of declaring a data type. So, you declare it first, you have the data type string, and then you have the name result, which is the name of the variable, and then in the next line of code, they actually assign it a value. They say result equals, so result here is the same thing as result here. So they're the exact same thing, but they're just doing it on two different lines of code. They could have just as easily in the same line of code just said string result is equal to, and then had, everything that follows this J option pane here. They could have just had it after the equal sign. But in this scenario, they do it in two different lines of code. It's kind of good to be exposed to both ways of doing it. So just know that it's the same thing, string result, and then in the next line they have result is equal to. So result is just a variable name that they created in order to store the result of what they're going to ask the user. So in this case, let's start with the J option pane. So as soon as they have, result here, they say result is going to be equal to J option pane dot show input dialog. So that's the code for whenever you want to create a dialog box that takes users input. And so the first argument again is going to be null. You have your comma, and then you have your string. And obviously in this case, we're asking the user what their name is. So you would just type what is your name, and that is what's being displayed in this box here. So we're asking the user what their name is, and then you give them a little text field so that they can enter their name. But one thing to note is that result here, the reason we declare result is that whatever the user enters from the show input dialog, so in this case, they enter the word Audrey. So now Audrey, that value is going to be listed in result. So whatever the user inputs is going to be held in the variable result. So let's say they do enter Audrey. It's the same thing as saying string result is equal to Audrey. So instead of having, this entire show input dialog line of code here, it's just the same thing as saying this right here. They're just saying that result is now going to be equal to whatever the user enters. So in this case, they enter the word Audrey. So now result down here is going to be, the value of it is going to be Audrey, or maybe they could have wrote Bob or John. Whatever their name is going to be stored as the value of the string result. So that's important to take note of because we're going to be using that in the next line of code. For show message dialog boxes, which is the dialog box that we talked about earlier, you don't have to declare a certain variable to store results in, because in show message dialog boxes, you're not taking any input from the user, you're just displaying a certain message. So in this case, they have a second dialog box here, which is the show message dialog box. And the way they code that is kind of the same way. You have joption pane.show message dialog, open parentheses, you have null, you have your comma, and then you have your string. And you just want to, a really simple hello message, just a really, like a nice greeting. So, you open your string, you have hello, and, you have hello down here as well in the dialog box, and then you want it to display whatever their name is. So the name could change. This guy could have entered John, or could have entered, Richard or Bob, or whatever it may be. So you have to use result here. Now remember, you concatenate this variable with the string hello. Note that we said that result is what holds the value of whatever the user entered their name as. So if whenever they enter Audrey as the name, now result here holds the value of their name, and so whenever you write it in the code, it displays down here in the dialog box as the name that they entered. So result is just a variable that they created. They could have called it name, they could have called it name input, they could have called it result, they could have called it final result, whatever you want to call it, it's just the name of a variable that they created. So whenever you concatenate it with your string in your show message dialog box, it displays down here as the actual name. So hopefully that's not too confusing. If it is, maybe try to pause the video and just kind of look over the code, see what it's doing. Hopefully that breakdown was enough for you to understand it. So kind of just moving on with what a show input dialog message box actually does, as we said in the previous slide in that example, is that whatever the user inputs, whatever result they give you, if they give you their name or whatever, it becomes stored in a string. Like in the previous example, it was stored in the string result, so their name was stored in the string result. So now the question becomes, if the show input dialog box returns a string, which is what we said in the past, what do we do if you want to use the data as a number, right? So it returns the value as a string, but what if you want to use the value as a number? So that's where parsing comes into play. Parsing is the idea of changing or converting a string to a numeric data type. So converting a string to an integer or a byte or a float, a double, whatever it may be. Parsing solves the problem of when the user gives you a certain result, and whenever you get a result from an input dialog box, it's always going to be a string data type, but you want to do math with it, so you have to convert it to a number. And so in this example, they're asking the user for their age. So you're asking the user, what is your age? And let's say the user enters 20. So the user's age is 20, but you want to add 5 years to the age. But you can't do this line right here because it's considered a string. So right here, age string, which is the value that holds the user's age string, because that's where you're assigning the value to be, is a string, and you can't do math with a string because it's not a numeric data type. You can only do math with like doubles and integers and the numeric data types that we talked about. So you cannot do math with strings, so there has to be a certain line of code that goes right here that converts the string into an integer and then allows you to do math with that integer, and that's where parsing comes into play. So as it says here, it says that each primitive data type has a corresponding way of parsing it. So every data type has a certain method for how you can parse it. So these are just different methods. This is the actual syntax of how you're going to be parsing certain numbers, or rather certain strings into certain numbers. So it's the same example that we talked about in the slide above. What if you want to ask the user for his name, and then you want to add 5 to the user's name? So you declare a string, call it age string, you ask the user for their name. Let's say the user enters 20. So now age string right here holds the value of 20. But we want to add 5 to 20, but we can't do that because age string is obviously a string and it's not an integer. So the next line of code here, right over, is the line of code that we were missing earlier. you have to parse it. You have to convert it from a string into an integer, and that's critically important because you cannot do math with strings. You can only do math with numeric data types. And so in this case, you have to declare a whole new variable. So, they call it, they declare the data type int, and they call it age num. So it's the same thing, it's 20. Like, you want to convert 20 from a string to an integer, so we're just going to create a new variable, call it age num, and then you have to parse it. So this is the syntax for parsing it. It's integer.parseInt, or double.parseDouble, or short.parseShort. In this case, we want it to be an integer, so we use the syntax integer.parseInt. Now, the way it functions is that you have integer.parseInt, and then whatever string you want to convert, you put that in the parentheses here. So as you see, we have age string here, and we want age string, which is a string up here. We want to convert that to an integer, so that's the syntax for it. You create a whole new variable, you call it age num, you declare it as an integer here, and then you do the syntax integer.parseInt, and then in the parentheses you put whatever string that you want to convert. And so after you do that, now age num here, age num now holds the value 20. So age num is still equal to 20, but now this 20 is a string. So although it is a number, it's coded as a string, but after we've converted it to an integer, we know that this is an int. So now that it's an int, we can actually do math with it. So in the next step, you want to add 5 to that age because you want to tell the user how old they're going to be in 5 years. So you call a whole new variable, call it int new age, and then you have age num, which we said is 20 here, and then we just, plus 5. We just add 5 to it. So now new age, this variable that we declared here, now is going to hold the value of the user's age plus 5. And that's how you're going to find out what the user, how old they're going to be in 5 years, and then you can display that back to the user in this last statement here, system.out.print, and then you just say in 5 years you will be, and then you concatenate, which is the plus sign here, and you concatenate the variable new age. So whenever you put new age there, new age now holds the value 25 because you did 20 plus 5, and now new age is 25. But, it's important to note that the only way we got there is because we had to convert the string, which is what the user gave you. Anytime you ask the user for a certain input, it's always going to be returned in the fashion of a string. Even if the user is entering 20, which is a number, it's coded as a string because anytime you use show input dialog, the response that you get from the user is always going to be a string. So you have to convert it into an integer if you ever want to do math with it. So just keep that in mind. And here is the last method of dialog boxes. It's something called a confirm dialog box. You're not going to be using confirm dialog box that much. Compared to input dialog boxes and message dialog boxes, but it's definitely important to note. So a confirm dialog box, I'm not going to go into too much detail. If you really want to learn about it, you just read about it in your textbook, but for the purposes of this class, you don't really use it on the quizzes. But a confirm dialog box is kind of the exact same way that you're coding a input dialog box or a message dialog box, but a confirm dialog box gives you these options here. So it'll ask you, maybe you're asking the user something, or you want to display a certain message. So the code here says joption.show confirm dialog. Same thing, you have your arguments of null, your comma, and then whatever string you want to display. And then, you ask the user the question, and then it'll prompt you to either confirm yes or confirm no, or it'll give you the option to cancel. So confirm dialog boxes always give you 3 options: cancel, no, or yes. And the code here kind of, if you responded yes, then it'll tell you it's true. So if you want to pause and look at the code, you can do that. I'm not going to go over all of it. So those are the 3 dialog boxes. You have your input dialog, your message dialog, and your confirm dialog. And for the purposes of this class, you're mainly going to be using the show message dialog and the show input dialog, joption pane class options. So that's going to do it for the concept stuff for chapter 2. I know it was a lot to cover, but I would really stress that you learn this stuff because this builds the foundation of the programming that you're going to be doing later on in this class. So definitely make sure you understand this stuff down to a T. So that's going to do it for this video. Hopefully, you learned something. In the next video, we're still going to be doing chapter 2 stuff, but I'm going to be doing like hard coding examples that I've come up with, just to give you a better understanding of how to do math and how to do, using variables in math and how to ask the user for certain questions and how to parse user-given information into stuff that you can, manipulate mathematically. So I would definitely watch the next video, just to get better understanding of how coding actually works. So definitely stick around for the next video, and I'll see you then. Bye.